The goal of the MESH4U project is to develop and test multiple energy storage hubs through small and medium-sized enterprises in the industry to solutions that provide flexibility for end customers in local power grids and distribution system operators. The consortium leader is Elektrum Konkreo from Białystok, Poland. Other partners come from Germany, Switzerland, and Italy. Testing of different types and technologies was possible thanks to building demonstrators in different countries. They differ in weather conditions, but also have different needs in the use of energy storage.
As a part of the MESH4U project in Poland, energy storage was implemented at Alufro's automotive accessories factory. It stores energy from a PV farm installed on the roof of one of the production halls and is also connected to the control system. The general idea behind the implementation of the energy storage control system is to ensure full autonomy of energy storage operation and its full integration with the Alufro's facility.
Firma Alufrost od wielu lat jest producentem akcesoriów motoryzacyjnych. Dzięki temu, że zaczęliśmy współpracę z firmą Elektrum, mamy dzisiaj komfort pracy. Wcześniej mieliśmy problem ze spadkami napięcia, które powodowały, że przy każdym takim spadku napięcia maszyna się wyłączała, co łączyło się z wielkimi kosztami straty materiału, jak również uruchomienia ponownego maszyny. Magazyn wykorzystuje inteligentne algorytmy, dzięki czemu spadki napięcia już u nas nie występują.
The main task was to develop algorithm for controlling an energy storage schedule, cooperating with a PV power plant in an industrial microgrid. The demonstrator is technically and economically interesting because it allows multi-functional use of stored energy, on the one hand maximizing the use of green energy and on the other one maintaining the continuity of power supply.
Thanks to the implemented algorithms, it is possible to predict the generation from the PV plant and the energy demand of the plant, so the energy storage is able to set its operating characteristics in advance. The second equally important aspect was to ensure the uninterrupted operation of the plant in case of a grid failure. Such a solution can sustain the plant's operation without interfering with energy consumption. In example, maintaining the operation of the plant in the state it was in before the failure. The integration of the energy storage and the algorithms controlling is crowned by EMAX, master system which integrates the storage control algorithms, the control of the photovoltaic installation, and the monitoring of energy consumption by the factory. This way, it optimizes the operation of the storage in different operating scenarios, such as economic or technical scenario, and a tailor-made mix of both for an individual plant, importantly without interfering with the plant's processes.
Mein Name ist Timo Hesse, ich bin der Geschäftsführer der Art Möbel GmbH und in Zusammenarbeit mit dem Fraunhofer Institut Magdeburg im Namen des MESH4U-Programms haben wir investiert in unser Unternehmen, um nachhaltig und Kosteneffizienz und Energieeffizienz produzieren zu können. Und das ist das Ergebnis der Freiform einer CNC-Gefräß, wo sehr viel Energie benötigt wird. Und jetzt hier nach dieser Investition sind wir natürlich viel kostensparsamer bei der Produktion.
Welcome to the Renewable Energy Lab at the University of Rome Vergara. In this facility we have characterized the components used in the MESH4U project under different operating conditions. This is a crucial aspect, especially for components such as batteries and fuel cells that are significantly affected by external factors. For this purpose, we have used this climatic chamber that can operate from -70°C up to 108. The data collected have been then used to develop and validate numerical model implemented within the optimization framework used in the project. In fact, the main goal of the project is to exploit the flexibility option present in the system. Do so, a central controller is crucial in order to coordinate all the energy fluxes. In particular, we have focused especially on the control algorithm for stationary and mobility storage. The algorithm has been then implemented in the framework developed by the colleagues at the Fraunhofer Institute to control the human flexibility during the production process. The overall approach has allowed a significant increase in the self-consumption up to 80%, and strong benefit also in terms of environmental factor, decreasing the carbon footprint of the system.
So we are at the Swiss demonstration site of the MESH4U project that, concerning our part, was concerning two main aspects. The first one was to develop statistical models for the forecasting of EV charging sessions. So here you can see there are a couple of vehicles connected. And one of the problems and challenges was to predict not only the arrival and departure times of these EVs, but also their needs in terms of power, energy, and state of charge. And this was completely accomplished with pretty successful results. The second part was strictly related to the first, namely use this information to feed a so-called dispatch algorithm, where an aggregate of devices, of energy conversion devices that are not entirely controllable, photovoltaic panels for the energy production, EVs, batteries, and other stochastic consumers, were brought together in order to achieve what we call the dispatch plan. So the dispatch plan is essentially a day-ahead power trajectory that is computed in order to be followed the day of operation with a very high fidelity. And the purpose of the project was to show that thanks to the controllability of electrical vehicles, the dispatch plan can be tracked with a higher fidelity and with less usage of standard stationary battery energy storage systems. And this has been demonstrated not only numerically but also experimentally in this demonstration site.
The partner Upside Group brings to the MESH4U project a unique large-scale installation of 51 megawatt battery storage technology systems with a capacity of 75 megawatt hours. This system is used on the primary reserve power market, offering system services needed especially in power grids with a large share of RES. The main function offered at spot market for BESS, RFCR. Frequency Containment Reserve, AKE Primary Reserve Control, and AFRR Automatic Frequency Restoration Reserve, AKE Secondary Reserve Control.
A fundamental transformation of energy systems towards a low carbon economy provides the key challenges for the energy storage concept. Implementation of the MESH4U project will be fundamental for building the capacity of European companies to use renewable energy sources efficiently.